Okay. Good morning, guys. We have very poor attendance. Only three people. So they're in the celebration mode right now. So should I go ahead and proceed with the lecture, or what? What do you guys say? Because I had a plan of completing this important topic, of perpendicular and parallel to the axis. That kind of if load is there. It will be the eccentric, but it will be perpendicular or parallel to the axis. It's a kind of, again, important thing to understand. And I wanted good audience, at least 4 or 5 people. So we have one more audience is there. Sunil has also joined. So I know. I think I don't know. I will continue with my lecture. Okay. At least I was expecting 5 6 people, but anyway. So we will start with my lecture. Let me just share my screen with you guys. Okay. Okay. In the last lecture, we completed very important part, and we also took a numerical on that, right, for the eccentric loading. But that was time, that time we considered the shear failure, right? So the load was eccentric. It was not at the center of the gravity of the bolts, right, where for the bolted joint, but it was eccentric, and that time we considered shear. Now when shear comes into picture, we had shear as well as basically we tried to find out the load. Then we found out very big, so there will be two shear loads, shear stresses, primary and secondary. Primary because of the direct shear, secondary because of the torsion, right? So twisting. So we've combined those, and because both of them were direct shears, like shear type of stresses, we added them to find out the diameter. Now here, this is a similar eccentric load, but that this time it will be perpendicular to the axis of the bolt, right? So if it is what you can say, if it is parallel to the axis of the bolt, we have a different kind of stresses. If it is perpendicular to the axis of the bolt, we have a different kind of stresses, right? And if it is eccentric, it is away. So if it is not along the center of the, what you can say, uh, center of the gravity is not along that part, then we will have our double shear, whatever we have seen. So today we will see a load which is not in the plane of the bolt, right, but which is perpendicular to the axis of the bolt. Now whatever last case we have seen, that was in the bolt, was in the plane of the what you can say, shear, or the plane of the bolts, the load was. But today's case, the load, you see, if you see the diagram, the load is basically it is not in the plane of the bolts. It is away, in front of the plane of the bolts. So because of that, what will happen? Now the see concept is same for all type of problems. Concept is same. The load will be different, and accordingly stresses will be different. In previous case, right? Okay, so the case we have taken here, here the load was eccentric, but because of this load, there was a direct shear and secondary shear, right? So we combine those. So here in this case, now you just think what kind of stresses will be there. Now see the bolt, there are four bolts, and the load is perpendicular to the axis, right, and away from the plane of the bolt. So now what kind of stresses? Just imagine what kind of stresses will be there. You just think about it for a moment. Then we'll talk about how to find out the stresses. First of all, the because of this load, now this we will try to pull this particular bolt out, right? It will be stretched. So when there is a stretching, then there will be obviously what kind of load or stress is there for the tensile load. There will be tensile failure, right? And also because of this load, this all the bolts will be having shear, right? Direct shear, right? So now we have two types of stresses: direct shear and tensile stress. So how we will solve this kind of problem? By using principal stresses, right? When we have a direct tensile or compressive stress and shear stress, then we use either maximum principal stress theory or maximum shear stress theory, right? but we have to combine those two using the principal stress formulas. Are you getting my point? Again, I will repeat. Now, in the scenario where we have, load is perpendicular to the axis of the bolt, but it is away from the plane. That time we'll have two types of stresses in the bolts. First, this load, because of this load, we will try to stretch these bolts, and which will cause tensile stresses in the bolt. So we'll have a combination of this tensile, and also there will be direct shear, because of the obviously the load is acting, we're trying to shear the bolts, cut the bolt. If it is made of a very soft material, for shear, assume the bolts are made of a very soft material like a mud or like your dog. So that time, because of this load, it will simply shear. The shear will be pi by 4 d square. That will be the area avoiding shear multiplied by number of bolts. Are you getting my point? So shear failure is one failure, and another failure is we will try to stretch it. But now, since there are two stresses, one is shear and one is tensile. Combination of these two will be the cause for the failure of this particular bolts. We'll simply try to find out these stresses, put them, combine them, and try to find out principal stress and find out the diameter. Are you getting my point? It is straightforward problem. Similarly, another type, eccentric load, where the load is parallel to the axis of. Now, instead of this, assume this is the load. Load is, acting here. It is trying to pull. It is trying to pull like in this direction. So that time, what kind of stresses will be there? It will have direct tensile stress, and the tensile stress because of the stretching, right? So this P will be, again, it will be the direct tensile stress will be pi by 4 d square will be the area opposing tensile. So it will have direct tensile stress and tensile stress because of because of this you are trying to pull it out, right? So because of that, there will be two kind of, and we'll simply add those. So each and every problem will have this unique kind of combination. You have to just see like what kind of scenario is there. So in this case, we will try to find out now what are the stresses in the four bolts, and we will try to find out how we can calculate those stresses. Okay, as I said, in this case, when the load is perpendicular to the axis of the bolt, that time there will be direct shear as well as tensile. Now we have to find out by what stress this bolt will be stretched. So basically we have to find out tensile stress. How we can find that? So we will see that now slowly, step by step. Now assume that there are actually four bolts are there, but since 1 and 2, we will put it in two groups, 1 1 2 2, because 1 1 have exactly same kind of distance, same kind of stresses. Similarly, 2 is having same distance and same kind of stresses. So we'll have this normally it's now it's not 1 2 3 4, it's 1 1 2 2. Okay, to simplify the things. Now this bolt 1 is at distance L1, L2 is at distance L2. From this is now the point C is the point where it will try to rotate. Now when we are putting load here P, this whole thing will try to rotate along this point. So this will be stretched. This particular bolt will be stretched by distance delta 1. Delta 1 is a change in the length. And we are assuming that these are all rigid, right? We are assuming this wall is rigid, it is not bending, it is not flexible, and this structure bracket is also rigid. So if we assume that this delta n will be the change in the length of bolt 1, and delta 2 will be change in the length of bolt 2. Now it is very much clear from this. If we do triangulation, the delta 1 is proportional to distance of that particular bolt from this point C. So it is proportional to L1. Similarly, delta is proportional to L2. Right. So change in the length is proportional to its distance from because wall is rigid, bracket is rigid. Are you getting my point? So it is very straightforward that delta 1 is proportional to L1, delta 2 proportional to L2. So if we have another bolt delta 3, that delta 3 will be proportional to L3. Now how we will solve this? As I said, these kind of bolts will have two kind of stresses. One is tensile. Now see, this is delta 1 means it is being the length is changed from L to L plus, sorry, L1. So if say assume what it is, L is the length of the bolt 1, then L plus delta 1 will be its new length. So it will have an extension, and because of this, stress is proportional to strain as per the E is equal to stress upon strain is constant. So stress is proportional to strain. So your stress will be proportional to again the distance. So The more away your bolt is, more stress it is having. I will again repeat. If we assume this wall and the bracket as rigid, then the more the bolt away from this point C, it will have that much more delta, that much more change in the length. So since E is constant, stress is proportional to strain. So that the bolt is more away from this point C, it will have more stress. So stress is proportional to length of the bolt from the point C. Are you getting my point? It is very straightforward, right? So this will have tensile stress and also direct shear, and we'll combine those to find out the final stress. Okay, we'll see now how to approach it. But before that, we are making few assumptions. As I said, first is they are rigid. This assumption is important because we are assuming that they are rigid. So this change in the length delta will be proportional to its distance from C. Both are fitted and into ground holes. There are holes and which are finished good. Bolts are not preloaded. There is no preloaded stress in those. Stress concentration in the thread. We are not assuming any stress concentration. And all bolts are identical. Just to make our calculations easy. Now, because of the speed, now again, there will be shear force. As I said, that shear force will be, in this case, we will put the shear force as P1 dash, single dash. Okay. So that P1 is equal to P2, P1 dash is equal to P2 dash is equal to P upon number of bolts. Here 4 bolts are there. So each bolt will have P by 4 as the direct shear, as we have seen in the last case also. Alright. So whatever is the load divided by number of bolts will be your direct shear. It is straightforward. Okay. So P upon N. Now we will see how this is the shear stress. Now we have to find out the tensile stress in those. How we will find that? As I said, delta 1 is proportional to L1, delta 2 is proportional to L2, right? So force is now, for this force or the stress is equal to P upon A, right? So stress in bolt A is P upon A. Now area of all bolt is same. So your stress is proportional to load in that bolt, right? Now stress upon strain is equal to E. Since E is constant, stress is proportional to strain, and strain is equal to delta L upon L. Length is same, so it is proportional to delta. So E is dependent on delta. Sigma
2000 डेबिटचा मेसेज आला का बघ बरं तुला.
मला मेसेज काय येतोय? कोण आहे? गायत्री.
गायत्री, मला पैसे मिळाले नाहीयेत म्हणून तुला मी सांगतोय, बघ डेबिटचा आलाय का मेसेज. पैसे तर कट झालेत पण मिळाले नाहीत मला हातामध्ये.
ओके. ऋषिकेश
चल वळ.
ऋषिकेश बाळा, तू ऐकतोयस का? हॅलो ऋषिकेश, अरे दादा तू आहेस का माझ्या?
हा डिक्लाइन केलं का? बरोबर, ठीक. हा नाही आले, जाऊ दे. बरोबर.
ऋषिकेश, तो काय रिप्लाय करत नाही आणि त्यांनी म्यूट पण नाही केलेला. ऋषिकेश बाळ, तुला मी म्यूट केलंय, बट ऋषिकेश दिस इज नॉट गुड. लेक्चर मध्ये तुझे पैशाचे ट्रान्झॅक्शन चाललेले दादा. मी इथे जीव तोडून शिकवतोय रे बा. डोंट डू दॅट. पैसे तर ठीक आहे, चालू राहील. Okay, so I think we are out of Rishikesh's discussion now, so we'll continue with our lecture. So what I was saying is that I hope all of you guys are there and you guys are attentive. So I hope that, but anyway, so now let's continue. So I'll say like strain, as I said, the change in the length of each bolt is proportional to distance from point C. That delta will be, have dependency on the strain. The stress is proportional to strain, so it will have direct relation with your stress, and stress is will have, because area is say P. So all the forces in each bolt will be directly proportional to the distance from this point C. First, delta is proportional to L1. Since E is proportional to delta 1 and sigma is proportional to E and P is proportional to sigma, that's why tensile forces in each bolt is proportional to distance from point C. Okay, so we can directly say P1 is proportional to L1. L1 is distance of bolt 1 from point C, and similarly P2 double dash. This is now the double dash is direct tensile forces, right? So that is proportional to distance from point C. So now it is proportional. That means there will be some kind of constant. C will be P1 double dash is equal to CL1 and P2 double dash is equal to CL2. So it will have some kind of constant. We are trying to find out that constant. How we can find that? Now we'll take a moment. Okay, take a moment about point C. So what is the moment? Because of P, there will be moment P into distance, eccentricity E. P into E will be equal to, now this will be clockwise. Yes, and now there will be moment, load forces will be like this. So there will be anti-clockwise moment in 4 volts. In one there will be, see, force is P1 double dash, right? So P1 double dash into L1, right? Here they have mentioned it, P1 double dash into L1, and there are 2 volts, so there are 2 moments, P1 double dash into L1 plus P1 double dash into L1, so it will be 2 P1 double dash L1. Similarly, for the volt 2, there will be P2 double dash into L2 plus P2 double dash into L2. So these 4 moments, because of 4 volts, will be balanced by the moment because of the load. If we compare these, we will try to put P1 double dash is equal to CL1, and we'll get CL1 square. So this will come back to C is equal to PE into L1 square plus L2 square, 2 of that. Now see, this is exactly equal to whatever we have seen here. See, right here we have seen it is equal to PE upon R1, R2, R3, the square of the summation of that, right? So here also we are getting same kind of formula. C is equal to PE into P upon L1 square plus L2 square plus L1 square plus L2 square. See, thus, since the bolts two are, if they are not, symmetric, then we can take L1 square plus L2 square plus L3 square plus L4 square. So we are getting same kind of formula, whatever we got for the shear case. So we putting that back, we will get P1 double dash is equal to, now what is double dash? Tensile load is equal to PEL1 upon twice into L1 square upon L2 square. Okay. And similarly, we can get the load in bolt 2. So now, since now we are having, load in bolt 1, we are having tensile load as well as shear. Now shear is same in all 4 bolt, but tensile load is different in different bolt. Now where the load, see, now if you see here, it is P is constant, that is applied load, E is eccentricity, that is constant, L1 and L2 are constant, right? Distance of each bolt. Only variable is, in this case it is L1, in this case L2. So P1 double dash, that is tensile force, is proportional to its distance. So if you can clearly say, the more bolt is away from, it will have maximum stress, tensile stress. So the bolt having the farthest distance from the point C, if there are say 4, 5, 10, whatever bolts, the bolt having maximum distance will have maximum tensile stress. And since shear is same in all bolts, then combination of shear and tensile will be the maximum in the case which is having the maximum distance from point C, right? So we don't need to worry about this bolt which are having the distance less than that. We will design only this bolt, and then obviously this will be safe because we will be having less stress. Okay, so we are only worried about bolt positioned at 1 in this case. Are you getting my point? Because they are having the farthest distance, and they will be having the maximum tensile stress. And since shear stress is common, then this bolt will have failure. Okay, so again going back to here, so we will design, in this case we will not worry about L2 because L2 is smaller than L1, so we'll only design L1, and then obviously all bolt diameter is same, this will obviously be safe. Okay, so now as I said, we don't need to worry about now bolt 2, we'll only worry about bolt 1 for the design purpose. So now shear stress is equal to this whatever, direct shear P1 dash, we calculate this P1 dash is equal to P upon number of bolts upon area pi by 4 d square, and tensile stress is P1 double dash, whatever we just calculate, upon again area will be pi by 4 d square, right? If we put these, now these are the direct shear stress and direct tensile stress. Okay, now we have two types of stresses, and shear and tensile. To find out the maximum stress, it will be sigma t by 2 plus root of sigma t by 2 square plus tau square. This is principal stress theory. And if we consider maximum shear stress theory, it is sigma tau upon sigma t upon 2 by 2 square plus tau square. So we can use any one of these. The sigma 1 allowable will be your SYT upon factor of safety, and tau will be 0.5 SYT upon factor of safety. So we will see whatever stress, either principal stress theory or principal shear stress theory, and we can calculate the diameter. As I said here, sigma 1 is equal to SYT upon factor of safety, and tau is equal to SSY, which is 0.5 SYT upon factor of 50. So we will consider both of these, and with whatever we will get the maximum diameter, we'll use that diameter for our design. Okay, and we have to use the combination because we have tensile as well as shear stresses. Okay, are you getting my point? So this is now, okay, it is clear. This is now eccentric load, where load is perpendicular to the axis of the board. Now assume that load is, this case is now completed. Okay, now assume that the load is parallel to the axis of, in that case we'll have tensile stress because of this, whatever we calculated, P1 double dash, right? P1 double dash we calculated here is equal to PEL1 upon 2L1 square upon plus L2 square. And again, there will be one more direct tensile stress. P upon P will be divided by number of bolts upon this area pi by 4 d square. Are you getting my point? So the case of eccentric load with load having, it is parallel to the axis of the bolt, it is almost same case, but instead of principal stress theory, principal shear stress, we can directly add those, because both those stresses, see the load is like this, both the stresses will be tensile. One is direct tensile and one is a tensile, secondary tensile because of the is twisting. Are you getting my point? So that also problem we can say solve by similar approach. In that case, we will have P1 double dash is equal to PEL1 upon 2L plus L2 square, and P1 single dash will be again like this only. P1 single dash will be P upon number of bolts. Okay, but in that case we'll have P is equal to not like this. Total P is equal to P1 double dash plus P1 single dash. Okay, clear? Any doubt? Or I can go ahead with my numerical. We will see now numerical on this. Okay. You guys, if you guys don't have any doubt, I can proceed. Any doubt you can ask me. We have a quite good attendance. I was not expecting this. We have 11 people or 10 people joined, so which is awesome. I'm happy about it. Let me just save the attendance. I'm giving this 1 minute for the any query if you guys have. Otherwise, I will proceed with the numerical. Okay, so since there is no reply from you guys or no query, I will proceed with my numerical. Now we have 10, 20, 14 minutes, so it's okay, we can finish the. So see, it's basically same numerical, but here they have given load, eccentricity. Load is given as 25 kilonewton, so basically 25,000 Newton, eccentricity 100 mm. Distance of bolt 1, there are two bolts. 150 and distance of two bolts are given as, so the closer bolts are at 25 mm and the bolts which are having farthest distance is 150 mm from point C. There are no preloads. Okay, somebody said something. Yes sir, please proceed. Thank you Kunal. I am proceeding with my numerical. There is no preload. So if there is preload, we have to just add this to the load. So in this case there is no pre-stress is given. The bolts are made of plain carbon steel 45 CH, so SYT is given. So we clearly know SYT, that means your SYT upon factor of 52.5 will be your allowable tensile stress, and multiplied by 0.5 will be allowable shear stress. See, like here also the load is we have noted down given, SYT P is noted down, SYT is noted down. Let me just change the color of this so that we'll go step by step. Okay. So we are given a load 25 kilonewton, SYT 380. So divide this SYT by factor of 50 to get you allowable tensile stress to use in sigma 1, right? So to use it here, and multiply by that by 0.5, it is 380 upon 2.5 factor of 50, that is your SYT allowable sigma t, and then multiply by 0.5 to get you down allowable shear stress. So we can get both of these stresses by using these two. Okay. Now again, as I said, we have given this load. So let's see the diagram again. So this is the assembly. There are 4 bolts are there. Okay. The bracket is having load of 25 kilonewton. The eccentricity is given 100 mm. So the moment is 25,000 into 100. So it is 25 into 10 raised to 4 multiplied by 100. So 25 into 10 raised to 6 will be your Newton mm will be the moment because of the P. Okay. So let's try to solve this problem. Okay. How we will solve it? First of all, we have to we noted down here. We'll find out the allowable stresses, right? So tau allowable is, as I said, SSY upon factor of safety, 0.5 of SYT upon factor of safety. So it comes to 76 Newton per mm square. So allowable shear stress is 70, and that will be allowable sigma T, my principal stress will be allowable, tensile stress will be a double of that, 152 Newton per mm square. Because, but here we are going to use maximum principal stress theory. Okay. Now there are with this load there will be two stresses, right? First is direct shear P upon 4. So 25,000 upon 4 will be 6 4 the 24 and 225. So 6250, 6,250 Newton will be direct shear load into each bolt. Okay. Again I will repeat. P is 25,000. So divided by number of bolts 4 will be your 6,250 will be Newton will be loading each bolt. So that load upon the area of the shear will be pi by 4 d square. So that will be your shear stress, 6250 upon pi by 4 d square. So we don't know d, we have to find the d. So we'll keep d as it is. So 6250 upon pi by 4 d square will be your tau, and that tau we know what is allowable tau. Okay, but we will use maximum principal stress theory. So that is, this is now principal shear, maximum shear stress. Now we have to find the tensile stress. How we can find the tensile load? Tensile load is equal to this. We are going to use this because this is maximum. P into E into L1 upon 2 L1 square plus L2 square, right? We know P, it is 25,000, E is 100, L1 we know, they have given L1, right? They have given L1 as 150 and L2 as 50. So we know all these stuff. So we can find out P1 double dash. Once we know P1 double dash, that is direct tensile stress upon pi by 4 d square will be your, again we don't know d, so we will keep it as it is. So we know direct tensile load. Let's find that. So now here the direct shear stress is equal to, or shear load actually, this is we are calculating not stress, but this is load. Okay. So shear stress is what? Tau is equal to load upon area. Now load in each bolt is P upon number of bolts, 6250 upon area, 6250 upon A will be your Newton per mm will be your shear stress in bolt 1 or 2. Are you getting my point? Right. So load is in each bolt is 6250 upon area. We don't know area. We have to calculate the area. So we'll keep it as it is. So 6250 upon area Newton per mm square is a shear stress. Now we have to find out tensile stress. How we can find the tensile stress? It is by using the formula we have just seen. P1 double dash. This is now tensile stress. P1 double dash is tensile load in the bolt 1. So PEL1, P is 25 into 10 raised to 3, 100 multiplied by 150 upon, add these two distances square multiplied by. Now these are basically why we are saying, because there are four distances, 150 square plus 25 square plus 150 square plus 25 square. Okay. So with this we will get tensile load in each bolt 1, not each bolt. Tensile load is more in bolt 1 compared to bolt 2. It is 8108.11 Newton. Okay. And we will do design of bolt 1, then bolt 2 will obviously set. So now tensile stress will be, now say area of the bolt is A. So P1 double dash upon A will be the tensile stress in bolt 1. So this will be 8108.11 upon area Newton per mm square will be your tensile stress in bolt 1. There are two 1 bolts. So now we know sigma T tensile stress, we know tau shear stress. So just we'll use maximum principal stress theory to calculate. Now what is maximum principal stress theory? Sigma tau upon 2 bracket square plus tau square. So sigma T is, we just calculate 8108.11 upon A, that is, see we are keeping A as it is because we don't know it. So 8108 upon 2 A, this is here, 2 is coming because of this, square of that plus shear stress we calculated 6250 upon A. So we don't know A, so we add these two, this will be your maximum allowable shear stress. But we know maximum allowable shear stress that we calculated here, that is 76. So match this with 76 to get you A. So if we match this, this will come to 7449.69 upon area Newton per mm square. This should be equal to your allowable shear stress, right? So if you match this with your 76, we get area as equal to 9. So 9 mm square, 98.02 mm square. So that is equal to your pi by 4 d square. So if we calculate that, you will get your area, for this, what kind of, if you go to that table, For what kind of area we have? Area is 98. Let's go to that table. I don't know where is that table. If we have area, area is here. What was the area? Okay, see, I'm just going through the table. Okay, let's me just see what I just forgot the area. Area we got is 98.02. 98.02 is the area of the bolt. Okay, let's open that table. 98.02. So we will be okay, this here. So we'll be using M. So here area is 84, right? For M12. For M14 area is 115. Right. So we will be using M14 as our what you can say, uh, M14 as your bolt size for the this particular. What I think they have used 60. See, I don't know. See why they have used 140, 157. Okay, but I think M14 will be enough because that it is 115 is the maximum area. So I think that is okay. So this is how we will solve the problem. In this case, we'll use M14 threads. So this is the case where the load is perpendicular to the axis of the bolt. We will try to find out the shear stress, and we will try to find out tensile stress, and you will combine those using principal stress theory. Now there is another type of problem where the eccentric load is parallel. See, I think that is the next topic we are having. Eccentric load parallel to the axis of the bolt. So the load will be eccentric, means it is not at the center of gravity, it will be anywhere, right? But it is parallel to the axis. Now that time approach will be same, but instead of shear, we will have tensile. Now we P1 single dash was shear. Here we will have direct tensile. P1 single dash will be pi by P upon number of bolts, that will be the load, upon pi by 4 d square, right? And secondary shear will be whatever we just calculated, right? Like using this formula. And since both of those are tensile, we don't need to worry about the principal stress. We can directly add those and we can solve the problem. Okay. So this is how we will approach any kind of problem. And after this, we are left with the design of circular base. So next time I will try to have sometime theory and a numerical on a circular base. Okay. Okay. You guys have any doubt about this? You can ask me. We have 5 minutes left. Otherwise, we can conclude the lecture. But if any doubt, I will give a couple of minutes in case you have any doubt. You guys can ask. I don't know how many are there. Out of 9, guys, just reply me that yes with yes or something in the chat, just to make sure that you guys are listening. I don't know how many of you guys. Just reply me in the chat. You guys are listening, and if everything is okay with you guys can say yes sir, and you guys can quit. No problem. You can close the session because today's I have taken a case perpendicular load, eccentric load, and we took a numerical on that. Also, we discussed the case of parallel load. So there is no I probably I will not take any numerical on that because I would like to take a circular base. Okay. So yes sir, Ravi said, I think many of you guys said.
एक्झाम स्ट्रक्चर सांगा ना कसं असेल, म्हणजे एमसीक्यू वगैरे काय
काय काय
आलंय ना. डिसेंबर मध्ये एक्झाम आहेत ना आपल्या.
ओके.
तर कसं म्हणजे एमसीक्यू टाइप राहील ऑनलाईन?
नाही ते मला ते काहीच सांगता येत नाही. आता शक्यता तुमची एमसीक्यू होण्याची जास्त आहे. ओके. त्यासाठी आता तुमचा डीएमईचा एमसीक्यू कसा असं कारण याच्यामध्ये आता थिअरिटिकल पार्ट तसा फार कमी आहे ना, याच्यात न्यूमेरिकल जास्त. तर तुम्हाला एखादं न्यूमेरिकल देतील आणि ते तुम्हाला सॉल्व्ह करून तुम्हाला त्याचा आन्सर देतील, त्याच्यातले तुम्हाला चूज करायचे, असं असू शकेल. मग आता अजून काय पॅटर्न बदलतील का ते काहीच माहित नाही. म्हणजे तुमची एक्झाम कशी होईल, पण प्रॉबेबली जशी आता झाली ना बीईची तशीच तुमची होण्याची शक्यता जास्त आहे मला तरी वाटतं. तर तुमची एमसीक्यू त्याच्यामध्ये समजा जर 50 मार्काची झाली तर त्याच्यामध्ये 10, 12, 15 मार्काचं, 20 मार्काचं विचारेल तुम्हाला स्ट्रेस वगैरे ह्या बेसिक गोष्टी, आणि 30 मार्काचे न्यूमेरिकल असतील जे तुम्हाला सॉल्व्ह करून आन्सर चूज करायचे, असं असू शकतं. त्याची अजून काही क्लॅरिटी दिलेलीच नाही त्यांनी, कारण की सध्या त्यांचं आता कॉन्सन्ट्रेशन हळूहळू बी कडनं शिफ्ट होऊन बॅकलॉग कडे गेलेलं आहे. आता they are now more worried about concluding the exam of the backlog people. But once that is done, मग तुमचं सोल्युशन. पण बहुतेक तुमची डिसेंबरच्या शेवटी किंवा जानेवारीच्या पहिल्या वीक मध्येची शक्यता आहे. असा एक आमचा
ओके ओके
अंदाज आहे प्राथमिक अंदाज. डिसेंबरच्या फर्स्ट वीक पर्यंत तुमचा सिलेबस उरकून जाईल आणि त्याच्यानंतर मग तुमची एक्झामचं होईल आणि एससीची थोडीशी लेट होईल कारण बीएससीच्या मुलांना त्यांना थोडासा द्यायला लागेल वेळ. पण
चालेल चालेल.
अपार्ट फ्रॉम दॅट मला वाटतं तुमची बहुतेक अशीच होईल जशी आता बॅकलॉगची होती.
चालेल चालेल. आणि सर एक्झाम फॉर्मचं अजून नाही ना भरायचं काय आम्ही?
अजून तसं काहीच आलेलं नाही. आम्हाला आलं ना आमच्याकडे लगेच तुम्हाला आम्ही पाठवू ग्रुपवरती. डोंट वरी. आम्ही लेक्चर
चालेल चालेल.
रोज होतातच आहेत. तर ते
हा, हा.
लेक्चरच्या प्रमाणे म्हणजे तुम्हाला लेक्चरमध्ये पण आम्ही सांगू. ओके टिल
हो
व्हेन
चालेल चालेल.
असाइनमेंट आता मला वाटतं असाइनमेंट माझ्या याच्यात आहेत. माझ्या
हो
क्लासरूम मध्ये असाइनमेंट्स आहेत. तर तुम्ही त्या असाइनमेंट
हो.
कम्प्लीट करून फक्त त्या कोपऱ्यावरती तुमचं नाव टाका जे काय असतील त्या
हा
आणि ते तुमच्या तयार करून ठेवा. कधी हवेत मी तुम्हाला सांगेल कधी पण जे काय असेल तर
चालेल
आपल्याला आपला सिलेबस संपायच्या अगोदर असाइनमेंट मला माझ्याकडे घ्यायचे तुमच्या सॉफ्ट कॉपी. ओके
ओके ओके. थँक्यू सर.
ओके चलो ठीक आहे. थँक्यू गाईज.